Question that one said, a piece of soft iron XY has a coil wound around it. The north pole of a bar magnet is pulled away. So we have a north pole here, pulled away, is pulled away from end X, which causes an EMF to be induced in the coil. You must understand that if the magnet is close to XY and the coil around it, then the magnetic field entering through XY and the coil is strong. When you start moving the magnet away, then the magnetic field is becoming weak, that is inside the coil. So there's a change in magnetic field, and this change in magnetic field induces an EMF in the coil. Okay, fine. Causes an induced EMF in the coil. The magnet is now turned around so that the north pole is on the left. So we turn around the magnet now such that the north pole is on the left. The north pole is on the left. The north pole was here, so now the north pole is on the left. The south pole is here. It is taken to the other end of the soft iron. So we then take the magnet, which is turned around, to the other side of the soft iron, with the north pole here and south pole here. And the north pole is pushed into end Y. The north pole is going to be pushed into this end Y. A new current is induced in the coil. Which statement is correct? A says the induced current is in the opposite direction and causes the soft iron core to attract the north pole. So this statement is wrong on two parts. They said the induced current is in the opposite direction and causes the soft iron to attract the north pole. Now, this part here is definitely wrong. All the times, if you are going to push the north pole into this one, this side must become north according to Lenz's law to ensure that there is a repulsion and there is an opposition to the movement of the magnet into the coil. Right? So this side becomes north, side Y, so that it opposes that north pole which is moving into it. Okay? Then the other part of this statement says the new induced current is in the opposite direction. The new induced current is in the opposite direction. Now, direction of the induced current in the coil can only be determined by, in this case, which side is north and which side is south. For example, in this case, when the magnet is being moved into like that, then this side is north and this side is south. So we want to see what was happening originally. Which side was south and which side was north. Now, when we are moving this away, this north was being moved away. So this side had to be south, so as to attract the north so that it doesn't move away to oppose the movement, which is according to Lenz's law. So we can see that in both instances, this side is south and this side is north, meaning that the current flowing here is always flowing in the same direction so as to cause this side to be north and this side to be south. So in other words, the true answer is this one, which says that the new induced current is in the same direction. Yes. And causes the soft iron core to repel the north pole when it is being moved into. Then number 36 says, a radioactive isotope of sodium has a half-life of 15 hours. The table gives data from an experiment to show how the rate of decay of the isotope varies with time. The background count rate has not been subtracted from this data, so this data includes the background count rate. So the question then asked, what is the background count rate in this question, of course? What is the background count rate? Now, to know the background count rate, what do? We must look at this data and understand that after one half-life, and we are told that the half-life is 15, after one half-life, we should have a decrease of the count rate by half. Now, since background count rate has not been subtracted, let's call that background count rate, let's call it X. So it means that originally at time 0, the actual count rate from the source is 400 minus X. Now, after one half-life, if we divide this one by 2, This is the new count rate after 15 hours. After 30 hours, why am I even considering 30 hours? We divide again by 2. So dividing this by 2 will become this by 4. So that is the new count rate after 30 hours, which is after 2 half-lives. Why did I consider this? Because I did not have 15 here, so the only thing that I had was 30. So in other words, the new count rate after 30 hours should be equal to 115 minus the background count rate, because that's the count rate without the background count rate. Should be 115 minus x. So then this becomes 400 minus x, and 115 times 4, which becomes equal to 460x. So this becomes 460x. 460, sorry, minus 4x. Then we take minus 4x to this side, becomes plus 4x, which is plus 4x minus x, which is 3x. We take 400 to the other side, which becomes minus 400. 460 minus 400, that's 60. So x is equal to 20. That's the background count rate. Then number 38, the time taken for the light to orbit, for the Earth to orbit the Sun is approximately 365 days. The average radius of the Earth's orbit around the Sun is 1.65 times 10 to the power of 8 kilometers. What is the average orbital speed of the Earth? So when we want to find orbital speed, we have to be clear. The formula for orbital speed is 2 pi r, which is of course the circumference, divided by the period, like that. Now, what are we given? We're given the period, time taken for the Earth to orbit the Sun, which is the period, was time taken for one complete oscillation, circular motion. So in other words, it's 2 pi times 1.5 times 10 to the power of, we must change it to meters, it's in kilometers, is 10 to the power of 8. So we multiply it by 10 to the power of 3, which becomes 10 to the power of 11, divided by the time, which is 365 days, times 24 hours in a day, times 3,600. So this becomes 2 pi times 1.5 times 10 to the power of 11. Then the other one is 365 times 24 times 3,600. This should give us 29885, which if we round off, this becomes 3.0 times 10 to the power of 4. Okay. Meters per second. Then finally, the Sun transfers energy to the Earth through electromagnetic radiation. What are two parts of the electromagnetic spectrum to which most of the energy belongs? When the Sun is transferring energy to the Earth, there are only two forms of energy. There are only three actually. There's infrared, there is ultraviolet, then there is visible. You should know how that X-rays are produced in an X-ray machine. Gamma rays are produced, of course, by nuclear fusion and fusion. So it is possible that gamma rays can be produced also, but in lower quantities. Then microwaves are produced by machines. Then radio waves are also produced by machines to some extent. So the only one which is left here, two parts of the electromagnetic spectrum to which most of the energy belongs to, which is coming from the Sun, is infrared radiation and visible light.